Okay, vectors, page 17. So if we have the vectors p and q, and we want to find the dot product of p and q, what we're going to do is we're going to multiply the 3 times the negative 2, the negative 1 times the 1, and the 2 times the 3, and we're going to get these three numbers, and then we're just going to add them together, add all these three numbers together, and we're just going to get negative 1. Okay? And then, so that is the dot product of p dot q, the number negative 1. Now if the dot product was 0, then that would tell us that the two vectors are perpendicular to each other. But since they're not, they're either parallel or somewhere in between. Okay? So how do we figure out the angle between p and q? Well, we have a formula which is that the cosine of theta is equal to the dot product of the two vectors divided by the length of each vector. Okay? So let's find the length of p and the length of q. So the length of p would be the square root of 9 plus 1 plus 4, which is equal to the square root of 14. And this one would be the square root of 4 plus 1 plus 9, which is also the square root of 14. So the cosine of theta is equal to negative 1 divided by square root of 14 times square root of 14, which is just 14. So the cosine of theta is negative 1 divided by 14. So the question is, what is theta? So theta is equal to the inverse cosine of negative 1 divided by 14. So let's do 1 divided by 14. We'll get that. And let's make sure that we're in the degrees mode, I guess, so that we'll get the answer in degrees. Yeah, we are. So we're going to take negative 1 divided by 14, and we're going to take the cosine of theta, that negative inverse cosine of that. So the inverse cosine of negative 0.0714 is equal to 94.1 degrees. So the answer is 94.1 degrees. They're almost perpendicular. Okay. Number 5. Find the dot product between this vector and this vector. And so they're just giving it to us in, the unit vector form. So we could also write this as 1, 1, negative 1 dotted with 0, 2, 1. So that's equal to 0 plus 2 minus 1, which is equal to 1. So the dot product is 1. I dotted with j. So I, remember, is 1, 0, and j, remember, is 0, 1. So the dot product of these two is just equal to 0, right? 0 plus 0 is 0. Number 7. Suppose that the length of v is equal to 3 and the length of w is equal to 4. State the possible values of v dot w if v and w are parallel. Well, if the two are parallel, then v dot w has to give us the maximum value, which is, 3, the length of v times the length of w, and the cosine of theta would be 0, so that would be 1. So it would be 3 times 4 times 1, which is equal to 12, right? Because the dot product is equal to the length of v times the length of w times the cosine of theta. So in the case of theta being 0, which is the parallel case, then v dot w is just the length of v times the length of w. At 60 degrees to each other, so that would be v dot w is equal to 3 times 4 times cosine of 60. And remember that the cosine of 60 is just 1/2, so that would be equal to 6. Now there is one other value that this could be. It could be negative 12 also, right? Because if you have it doesn't have to be theta equals 0 degrees. It also could be theta equals 180 degrees, because they could be parallel but in opposite directions. So those are two different values for 1. And for 2, at 60 degrees to each other, could be 6, and it could also be negative 6. Okay. C. Suppose that distance of C and distance of D is equal to square root of 5. What can be deduced about C and D if C dot D is equal to 5 and C dot D is equal to negative 5? Well, if C dot D is equal to 5, that means that we had square root of 5 times the square root of 5 times the cosine of theta. And if that's equal to 5, then that means the cosine of theta equals 1. And that means that theta was equal to 0 degrees. So they were like in the same direction. Okay, same direction. And then if C dot D is equal to negative 5, then that means that the cosine of theta was equal to negative 1, which meant that theta was equal to 180 degrees, which means that they were in opposite directions. Okay. Number 9. Use A, B, and C to prove that A dot B plus C is equal to A dot B plus A dot C. Okay, so we could take, first we're going to add B plus C together, so we'll get B1 plus C1, B2 plus C2, B3 plus C3, okay, and that would be dotted with A, 1, 2, 3. So these dotted together would be the same as A1 times B1 plus C1 plus A2 times B2 plus C2 plus A3 times B3 plus C3. Okay, and then, so that's this side right there. Now, what does it look like for this side? So that would be A dot B, so that would be A1 B1 plus A2 B2 plus A3 B3 plus A1 C1 plus A2 C2 plus A3 C3. Okay, all right, and then if we multiply all these out, we'll see that they are equal, right? We'll just use the distributive property. A3, C3. And then we can see that this is equal to that. Okay, so we've proven that. Okay, then it says, hence prove that A plus B dotted with C plus D is equal to A dot C plus A dot B, A dot D plus B dot C plus B dot D. Okay. Okay, now we're going to do this one here. So I'm going to do it in this space down here. So if I have A dot C plus A dot D, and I also have B dot C and B dot D, I could express this as A dot C plus D, right? Because I just prove this rule, right? So using that rule, I could change this to A dot C plus D. And likewise, I could change this to B plus C plus D, right? And then using the same rule, I could, you know, like, it doesn't matter which direction you dot product, so I could do C plus D dotted with A, and then C plus D dotted with B. I'm sorry, dotted with B. And then I could factor out the C plus D. So I could say C plus D is equal to C plus D dotted with A plus B is equal to that. And so now I've changed the right side of this to basically the left side of this. Okay, so that's it. 10. Find t given that these vectors are perpendicular. Okay, so if these two are perpendicular, that means the dot products are going to be 0. If the dot products are 0, that means 3 times negative 2 plus t times 1 is equal to 0. So that would be negative 6 plus t is equal to 0. So t is equal to 6. And in this case, it will be t times 3 minus 2 minus 3t plus t plus 2 times t equals 0. So let's see, that would be 2t minus 3t squared plus t squared plus 2t, which is equal to 4t minus 2t squared equals 0. So that would be equal to t, 4 minus 2t is equal to 0. So t would be equal to 0, or t would be equal to 2. And either of those would make this expression equal to 0.